All right, there was a couple things I wanted to get to before class ended, and we didn't get to them. So the first one is we want to find a statement like this, where it's very similar to this guy that we worked out, where we had to draw the triangle that we were looking at instead of just being able to look at our unit circle and get numbers. So same idea here. We want to draw a triangle that has a value of x and 2 for cotangent. And remember that cotangent is going to be adjacent over opposite. So if we're looking at this angle, remember this guy is just some angle. We don't know what it is. We're going to call that angle theta. That's some angle. So we need opposite or adjacent over opposite for cotangent. So x2. So this says that whenever I have this angle happen, I'm going to have, whenever I have a cotangent, the adjacent side is going to be x, the opposite side is going to be 2, x over 2. So then we need to Pythagorean theorem to find our missing side, which is in this case is the hypotenuse. So we say c squared. Let's go a squared plus b squared equals c squared. All right, so this is going to be our side C. So we know that side A is going to be x squared plus b. So side B is 2. So 2 squared is 4. Which is c squared. To get c by itself, we have the square root of x squared plus 4, and that equals c. So we can replace our side c with the square root of x squared plus 4. All right. So sine of that side, or sine of this angle right here, we'll call it theta, sine of that angle is going to be opposite over hypotenuse. So we're going to have 2 over the square root of x squared plus 4. You might be tempted to take the square root of x squared plus 4 and say, well, that thing is just going to be x plus 2. Not the case. Don't do that. All right. Not true. Not true. Not true. Not true. Don't do that. All right. But for the most part, we don't like square roots in the denominator. So we're going to rationalize the denominator a bit to get that thing to be a little bit nicer. So we're going to multiply by square root of x squared plus 4 times the square root of x squared plus 4. And we can then say that sine of cotangent inverse of x over 2 is going to be 2 times the square root of x squared plus 4 over x squared plus 4. All right, so that's a thing. It feels kind of gross because that doesn't feel like it should be an answer, but if we take sine value of this angle theta, when we have established that x and 2 need to be here based on this cotangent inverse, when we've established that, we need to then say, okay, sine is going to be 2 divided by the square root of x squared plus 4. So then we end up rationalizing our denominator and we get that thing. Okay, so that's how those are going to work. Find the angle and then take the sine of that angle. So here's a similar thing. We just have to do it more than once, right? So the quote-unquote trick of this is remembering that this thing right here and this thing right here are angles. Those are angles. Let's go ahead. We'll call them, how about u and v? All right. Sine of some angle u and some angle v. So we have sine of u plus v. We have an identity that is this thing. Sine of u plus v is sine u cosine v plus sine v cosine u. Same idea, same thing. Okay. So now we can just switch our angles back out. Whoops, wrong button. That was embarrassing. Switch our angles back out for what they are. But notice this guy is on our unit circle. This guy isn't. So we'll deal with that in a second. So we have sine of 1/2 times cosine of 5 cosine of cosine inverse, I forgot the inverse, cosine inverse of 5 over 13 plus sine of cosine inverse of 5 over 13 times cosine of sine inverse of 1/2. Okay? Well, from the first thing we talked about today, sine of sine inverse of something that's between 0 and, or between -1 and 1 ends up being just whatever the thing is. So this is going to end up being 1/2. Okay, so those are just going to cancel out really nicely. 5/13 is not on our unit circle, so we're going to skip this second part for right now. Then if we go into this third one, well, that's again cosine of 5 over 13, still not on our unit circle, so we're going to skip it. And then we're going to look over here. Well, sine inverse of 1/2, the angle that gives us a sine value of 1/2 between negative pi over 2 and pi over 2 is 30 degrees, or pi over 6. So that is cosine of pi over 6, which then becomes the square root of 3 over 2. So that's the cosine output of that particular angle, pi over 6. So then, just like we did a couple on the last problem and the problem before, since we have an angle that's not on our unit circle, we need to build a triangle for it. All right, so cosine of 5 over 13. So cosine, we're going to call our angle right here. Cosine is adjacent over hypotenuse, 5 over 13. So then we Pythagorean theorem to our answer. 169 minus 25 is 144, and the square root of that is 12. So if we take cosine of this angle that generated this triangle, the cosine of this angle is, well, cosine of that angle. All right, so that is 5 over 13 plus sine of this angle. We're looking now at the opposite side over the hypotenuse, and we get 12 over 13. So when we combine all of our like terms and when we simplify our fractions a little bit, we get, let go, thank you. Whoop. Come with me, thank you. That was so nice of you. Okay, so now we multiply across the top, we get 5 over 26 plus 12 square roots of 3 over 26. Or we can just combine them into one big fraction that ends up being 5 plus the square root of, gross. Come on, brain, work with me. 5 plus 12 times the square root of 3 over 26. Okay, so what this is meant to demonstrate is that since these are just angles, we can just plug them straight into all of our identity statements as just a thing, and then we can calculate out what that thing is later. Okay, all right, so hopefully that will be all you need to knock out the homework for tonight. Again, if you have questions or anything, let me know. And if you want to hang out after school, I'd be more than happy to talk to you, or at lunch or whatever you need to do. So have a great day, and I will talk to you later.